HanselMinutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman, hosted by Carl Franklin. This is Lawrence Ryan announcing show number 166, recorded live Friday, June 19th, 2009. Support for Hansel Minutes is provided by Telerik RAD Controls, the most comprehensive suite of components for Windows Forms and ASP.NET web applications. Online at www.telerik.com. And by .NET Developers Journal, the world's leading .NET developer magazine. Online at www.sys-con.com. In this episode, Scott talks about Windows Presentation Foundation with Ian Griffiths.
Hi, this is Scott Hanselman, and this is another episode of Hansel Minutes, and I'm sitting down here in Norway at the Norwegian Developers Conference, and I've got Ian Griffiths with me, who is a freelance WPF consultant and also a Pluralsight instructor and course author. Thanks for chatting with me today.
Oh, thanks for having me on.
I'm continually trying to understand WPF, and I started with my Baby Smash application, which I wrote incorrectly, and then I'm trying to make it more correct, and now I'm working on another WPF project I'm calling Shoebox Scan, where someone could basically talk to a scanner and put a bunch of photos from their shoebox and then do some work. And you just spent the last hour with me kind of correcting my mistakes, and we hit an interesting wall. And I think that that's a nice kind of metaphor for what I think a lot of people who are using WPF are doing. I really thought about it in terms of WinForms and in terms of Win32. You went with me very kindly, running screaming against the wall until we finally hit it. Maybe talk to us a little bit about what we tried to do and what went wrong and now what I'm going to have to do to go forward.
So this is a very common pattern in WPF application development. And as I tend to tell people when I see this sort of thing, I found all the WPF apps I've worked on have fallen into one of two categories. One is where I build a separate class that manages all the interaction stuff that's completely separate from the code behind and the XAML. And then there's the applications where I wish that's what I'd done. And we're in the former one because that's the path of least resistance, right? You sit down in front of the Visual Studio Designer and wonder why the XAML editor doesn't seem to do very much, but then you get used to that and you start writing code and you think, okay, I've got to get a bitmap on the screen. I'll use this image tag. That seems to work. Oh, I can make it do stuff. I can resize it. I can maybe have extra stuff layered on top of it to represent the scans in your example. I can drag stuff out, and everything ends up kind of getting baked into the view. You start using WPF's visual tree, which is the structure that represents what's on the screen, to hold your application's state. And it can either be what you might think of as model state, the underlying ideas that are part of the application, or it might be more transient stuff that's not really part of the model, like which things are selected right now. Am I in the middle of a drag operation? Do I have adorners lit up because this is the thing I'm dealing with right now? And all of these things can live in the view because that seems to be the obvious thing to do. Right.
So to put this into the context of the application so that people who, of course, can't see this because we're on a podcast, I'm trying to make an application where I can scan the entire scanner platen, which has a number of pictures on it, and then I want to drag rubber bands around them. So I might have 5 or 10 pictures that are being scanned in one pass. I've been holding all of those in, like what you said, the visual tree. I've got 10 little small wallet-sized pictures. They're held very nicely in the visual tree. I figured they're inside of a canvas, and I'll spin through them later. And that's not a good idea, is what you're saying.
It's almost always a bad idea in the long run. What tends to happen, and exactly what we saw happen just now as we were walking through it, is you suddenly get to a point where things just seem to be impossible. It's like the complexity has exploded because you're having to try and hold in your head what it was you meant by this particular thing in this place in the visual tree. It's like, there's a content control there that signifies this particular thing to my app.
Right.
And obviously you're trying to write code that's embodying relatively straightforward concepts. So we had the idea, which was, we want to make sure when the user drags an outline onto the image that they're inside the image.
Right. We were finding that we could drag the image all the way off the form and off into space. And I said, I want to bound that inside of this. So we only had really two places. There was the XAML and there was the code behind. And that's everything we were doing. And that was the only interaction, was just you and I trying to get the XAML to do what we could get it to do. There was only code behind. We had no other classes.
And that's a problem for a couple of reasons. One of which is it makes the code really hard to follow. The really quite simple ideas you want to represent don't look that simple when you come to write the code. You end up with all sorts of stuff that is dealing with either putting things into the view or taking them back out again to get back the information you first thought of. And you just get, and also the other problem is you get a lack of testability. How on earth would you write a unit test to say that the user can't drag something outside of the bounds of the image there? That's not going to be a particularly easy thing to do. You're probably going to end up having to use something like an automated test framework with UI automation support to feed fake input into the UI. And that's a bit of a nightmare. That's not the right way to go about testing some code, which should ultimately be no more complex than this number is no less than 0. This number is no greater than that bound. So clearly the code's in the wrong place.
Right. And once again, I found myself writing WPF code in a WinForms state of mind.
Right.
Until you finally said, all right, we've got to stop. It's nice that we got it working 80%, but everything we've done is wrong. So then you said we need to do a view model. And we hear this term more and more because we're hearing it in the ASP.NET MVC world and view model, and I'm hearing it in WPF. Maybe explain the concept of view model versus just the model and just the view within the context of WPF for our listeners.
Okay, so just to add to the confusion, there's at least 2 popular names this thing goes by. Some people call it the view model, some people call it the presenter. And more generally, you sometimes hear this idea referred to as separated presentation. I think that's the term that the Prism guys use for this exact same concept.
And what is Prism?
Prism is I think it's technically application guidance, but it's actually a bunch of code that you can download for doing composite applications in WPF and Silverlight.
And for those of us who don't speak English, composite would be composite applications that are composed of other controls. And
things. It's particularly aimed at teams where you've got a lot of different teams putting pieces into a single application and you want it all to work in concert. It tries to deal with those sorts of integration problems. So it's not unique to that style of app, though. The view model concept works in pretty much any UI. And the idea is this. Your model typically contains things that are specific to your domain. So whatever you're trying to work with, that lives in whatever ideas your application tries to deal with, those live in the model. But most user interfaces have stuff that has nothing really to do with the model. That's much more to do with the interaction. So the classic example is a drawing program. You take something like Adobe Illustrator. That has the model, which is the drawing, the shapes that are in the drawing. But the program has the ability to let you select an item in the drawing, and it lights up with adorners and other things you can drag around. Things in the toolbar will change. And that's more to do with the structure of the interaction. What happens when the user starts to push a mouse button down? What state changes occur? Because you have state machines, so things like drag operations. If you look at something like multi-touch interfaces, where you're dragging a bitmap around with your finger, then you put a second finger down to resize it, to do that kind of squeeze thing. Your interactions are going between different states. And you've got to have somewhere for that state to live. You've got to have somewhere for the extra information that needs to appear on screen that during the interactions that doesn't belong in the underlying model. There has to be a place for that to live. And people seem to default to putting it in the view because nothing really drives them to put it anywhere else. And this is the thing that is kind of not really understood, that there has to be a place for that to live. And that's what the view model is for. It's a separate class that is the home for those sorts of things.
So one of the words that you've mentioned a couple of times that we haven't defined yet is as an adorner. And there's really, this word is a little overloaded because there's the notion of an adorner in WPF, but then there's also the general concept of something being adorned, like you made the comment in about Photoshop, that I've got some item on the screen, and when I click on it, perhaps there's going to have resize handles, or it's going to have a little lollipop sticking out the top that I can grab and then rotate, where I've adorned this item. It's not part of the model.
Yeah.
It's not really part of the view, or it's transiently part of the view.
The view has to show it, but the view shouldn't be the thing that knows that it's supposed to show it.
Hence, a model for the view or view model.
That's exactly it, yeah. And just to talk a little more about the adorner thing, in general, all you said is the basic idea of an adorner. WPF happens to provide some infrastructure to solve some of the common problems, because you want the adorners to float to the top, but you also want them to follow around the things they're adorning as you zoom in and pan and rotate. And it just provides a little bit of infrastructure to try and make that easier. But it's a more broad concept than that. As you say, most programs that support interactive selection have something like that.
So, about an hour into our exercise working on our little scanning application, which I'm going to put up on Codeplex, and I've had a number of other people help me with on on Twitter. It's still not quite there. I think that you actually said I was basically screwed. And,
pretty much, yeah.
Pretty much. What am I going to have to do to fix this? Right now, you and I ended up with, I think, about 5 different functions that were all in the code behind, and we really got close. And the point where you said I was in trouble was where we have our scan, and the scan looks great. I can drag rubber bands, or what I'm calling rubber bands, I mean user scalable, rotatable, transparent rectangles that I could say scan this area and this area and this area. And then we started dragging it around. We had a little preview window that was showing how this was going to get cropped. And then we drug it right off of the form and kind of off into non-client area. And you said, uh-oh. I could see the wheels turning in your head. And you're like, yeah, there's constraining this, getting this to behave correctly is going to require you. You said rewrite, and I'm hoping you meant refactor this application. Yeah,
I mean, it's a restructuring. It's not going to be a complete rewrite. Really, it's a question of moving the logic around, but quite a lot of that logic is probably going to have to change. And the good news is it's going to look simpler when you're done. Because the problem is right now you've got decisions the code is taking, which is thoroughly intermingled with stuff you only had to do because you were dealing with a visual tree.
It is very, I would describe the code you and I wrote as very intimate in that we are very much poking around inside the view, trying to bend it to our will.
Yes. And that's absolutely what we don't really want to do.
So this is one of the things I think that is holding WPF back, is that it's unclear to a lot of people, at least from the point of view of the tooling. I mean, when you say file new WPF application, there's nothing that says, and here now make a view model, right? So
right.
There's no guidance there. How is someone supposed to know this?
Unfortunately, I don't have an answer to that, other than maybe we could record podcasts talking about this sort of thing, right, and maybe produce demo applications that show how it's done.
But isn't this holding WPF back?
I think it may be, although it does sort of depend on what kind of thing you're building with it. I mean, Dev 10's got stuff that's coming that's going to make some of the classic line of business application type data binding scenarios easy to use. And
right.
I think actually probably in that world, carrying on working like you think you're in Windows Forms may actually work just fine, so long as you're building the kind of application that would have worked the same way as it does in Windows Forms.
Is this my problem? Is this an issue that I'm writing apps that aren't typical apps? I mean, I'm not writing data binding, HR, human resources management applications. I'm writing either Baby Smash or, obscure scanner application. Am I picking the exact wrong scenarios for WPF?
Well, no, this is the interesting thing. I think you're picking exactly the kinds of scenarios that WPF makes possible, so long as you set about it in the right way.
Okay.
This is the kind of thing that would be really difficult to do in Windows Forms because of the kind of graphic stuff you require.
Right.
What you would have ended up doing is writing your own small version of WPF. This is part of the reason that people like me were very enthusiastic about WPF, was we looked at it and went, wow, this does all the sorts of stuff I've had to write time and time again in my own Windows Forms.
I will give you that. That's a good point. I haven't had to do a lot of thinking about graphics until the very end of this scanner thing. I mean, ultimately, my image control was handling resizing of the image. We've dropped these resizable rubber bands on top of it, and they really kind of just worked.
Once we got them in the right place,
right.
Yes.
Once they were, so talk about that actually, that's an interesting point, that the notion of the visual tree, and we had these adorning layers on top of an image, these rubber bandable, scalable areas on top of the image. And
we had asked WPF to resize the image for us, but we hadn't managed to ask it in such a way that it knew that we also wanted the adorners resized at the same time.
So what was happening was I'd have a scan, say, of like Ian's headshot, and then I would resize the application. The headshot would resize, but all my selection rectangles stayed small.
Right.
And I said to myself, gosh, isn't this the kind of stuff WPF is supposed to do for me? And you used a tool called Snoop.
Yeah, now Snoop is awesome. Snoop lets you just go and look at the visual tree of an application while it's running, so
right.
You can see what you've got, because you end up, the visual tree changes.
Right.
You initialize it with XAML, but a whole bunch of stuff can happen at runtime to add new things, and it's often difficult to know where things are with relation to each other. But with Snoop, once you attach it to a process, or a process for your American audience, we can just you can just move the mouse pointer over the thing you want, hit Control-Shift, and it will expand this tree view,
right.
showing you where you are and how you got there.
So for the MFC people and the C++ people, this is SPY++
yes.
for WPF. And what was funny is that I'd been pounding my head against the monitor for a number of hours over a number of weeks in my spare time. You popped out the right tool and said, oh, and within 5 minutes you realized that the thing that was doing the resizing did not know about my rectangles, and you just changed the XAML, you copied them in, and suddenly things just worked.
Yeah.
And that's one of these things where with WPF I'm finding that it just works until it completely doesn't work.
There was actually also an extra gotcha there, which is probably worth talking about very quickly, which is we had two elements, both of which were sort of doing that very polite British English thing of standing by a doorway and going, no, after you, no, after you. We had the image element and the view box were both offering to be as big as they needed to be. They're both saying, well, I can stretch to fill whatever space you've got. And the view box is saying, well, I can resize you to make you fit whatever space we've got. And we actually had to tell one of them, look, just be this big.
Do you know how to make the possible out of the impossible? Well, the .NET ninjas at Telerik do. They just released a huge pack of web controls all built on top of ASP.NET Ajax that'll help you build impossibly fast and interactive applications in no time at all. They've made the impossible possible in desktop development. If you think you can't have a carousel component in WinForms, well, you can. Their Windows Forms suite features a super powerful grid view control and 32 other crazy desktop components that'll give you dazzling WPF-like features, but in WinForms. They do the same thing in reporting solutions with a new design surface like nothing else. Looks just like graph paper. Gives you advanced page layout capabilities. Makes it feel more like a graphic design software than a reporting solution. Go check them out at telerik.com and be a .NET Ninja. And thanks for listening. So that actually brings up an interesting point. We should talk a little bit about some of the basic elements in XAML, the ones that are most useful, and I'll enumerate what I think they are, and I'd like to understand, if someone were going to sit down in an application, they should think about the grid, the view box.
ViewBox is important if you're dealing with kind of dynamically resizable, stretchy things. If you're not, then that's all it does. So I would not count that as fundamental. I would say that's extremely useful for specific scenarios. Okay, so then the grid, then the canvas. The canvas is also important. I'd rank it below the grid, but still important.
Okay, so what else am I missing here?
I would say items control.
Items control.
It's hugely important, and we're not using it yet, and we should be.
Okay, let's talk about the grid and the canvas, and then talk about the items control and how that would change the structure of my application.
Okay, so the grid is the single most important of the layout panels, and panels are elements in the elements that do layout. They contain multiple children and decide where to put them. That's their job. So the grid lets you basically carve the space up into rows and columns and position stuff. And it may not sound like much, but that turns out to be enough to do a huge range of different styles of layout. Mm-hmm. Canvas is for a different scenario where you don't want dynamically adaptable layout. That's when you want to say exactly where something is. So in the case of your little rectangle things, you want them to be in a precise location because the user drew them there. And you don't want that to move just because, the window changed size. So the canvas is great for when you need to be in control. Okay.
Now, right now, I'm letting this, the grid hold all of my, little selection items.
Yes.
Is that right? And I have no other data structures that know about that. I don't personally have a collection of selected photos.
Yeah.
The view is holding this for me, and I figured that was convenient.
And when we want to find out what selections you actually have, we have to walk through the view to go and find all the controls in there.
Since I don't own the data, I have to interrogate my view and hope that nothing horrible has happened.
Yes.
And you're saying that the items control and maybe an item template would be a more appropriate way of doing that, which would really split that logic, the showing and the knowing.
Yes. And the way I tend to think about it is in terms of a projection. I'm always in two minds about using that term because there's something of the kind of computer science degree about it, and it may scare people off, but it is an important concept.
But isn't it just document view like we learned 20 years ago?
It is, but the relationship between those two things is a projection. It's taking information in one form and converting it into another form, which is to say the view. And it's understanding that it is a projection is the important thing. Mm-hmm. That is the nature of the relationship between the document and the view. So yes, it's the same idea. I use the word projection partly because that also gets used in things like link. Link to SQL. You project data from the query into the target. It's essentially the same idea. You're running a transformation. And the critical thing is you have some underlying information and then you transform that to get it into the view. You sort of, rather than having the two be closely intertwined, to be unpleasantly intermingled to the extent that they are now, the data just is, and then you are able to project that onto the screen, and that's the job of the view. And items controls are important when you're dealing with multiple things, because they're what let you take any collection and project that into some things on the screen.
Okay, so what you're saying is that I need to have a data structure that is not automatically drawn to the screen, that actually says, all right, selected items or selected photos or, some appropriately named thing.
Yes.
They might have coordinates, they might have rotation, and they might have, size and things like that. Really, and whether or not they're selected, I guess, even.
Yes.
And they don't say anything about how they are to be displayed.
Correct.
They're just collections of numbers, basically a list of structures.
Yes.
And then what do I do with them?
One extra thing I want to point out there is that the slightly tricky thing about this idea is that this thing, which I would call the view model, does not depend on the view. It never goes and looks in the view. It never expects to find a bunch of controls. It's more passive than that.
I can test it. I can talk to it. I can do whatever I want. It's
exactly.
Just a list of stuff.
Fire it up in a unit test. You don't need to have a window there for it to work.
Okay.
But although it has no dependency on the view, it is very specifically for one particular view.
That's a really interesting point. We should kind of talk about that for just a second. It is intimate to the view. It is for the view. It is for no one else but the view. But it has no dependencies on the view.
Exactly.
Okay. All right. So then I've got this list that describes what I want to show, but not how to do it.
Yes. And to be a little more specific and precise about that, it's not saying how it should be rendered. It is making certain commitments about what sorts of information will be visible.
I like that. It's making commitments.
Yes.
It knows it's in .NET. It knows it's going to be on the screen at some point. It may make a commitment to let's say a coordinate system.
Yes.
Is that a reasonable commitment?
Yes, exactly. That sort of
How
thing.
far should it go before it's committed too much?
That's a very tricky question to answer.
An example would be
actually.
let's say I'm going to display myself as red. Do I use, brush objects and different things that are specific to WPF and store those and hold those, or is that knowing too much?
I would say that is right on the margins. I certainly have done that, and I have yet to come across a situation where I've regretted doing that, and yet it makes me feel slightly uneasy.
Because suddenly you're not just committing to basics like location, but now you're starting to get into...
You are bringing in user interface types to
Right.
to what you're exposing.
Should I have my own... Like what if I was could I hold a button? Like if I made see, now you're getting uncomfortable. I can tell in your face.
I have done that and I didn't enjoy it.
Right.
And actually the reason I did that was to work around an interesting feature of Silverlight where it was unable to do something for me, but
Okay.
I forget exactly what that was.
But really, what price your soul?
Yeah. And actually for me, I think the big difference there, the reason the button pushes me over the edge is that the button is an interactive user interface entity.
Unarguably.
A brush is not. A brush is more of a descriptive thing. A brush says how you would like something to be painted in.
Okay.
And the view still has the freedom to decide what to do with that brush, where to paint it. It's a slightly different character of thing. A button's a bit too much of its own entity.
Okay, so that gives us a sense of what where to stop. So I've got this list of stuff, and I want to describe exactly how to show it. Now, in our example, I've got a list of selected rectangles, and I want to display them all over this larger scanned image. How do I tell in the XAML to lay this out appropriately? I know how I did it in Baby Smash. I used an item template, and I did some data binding.
Okay.
It was fairly inscrutable, though. The data binding syntax I found to be a little difficult.
Okay. Well, I would say in your application, a fundamental idea of the application, part of the whole purpose is to pick out points and regions on the image, right?
Exactly.
So I think it will make sense for your view model to be exposing coordinates of some kind.
Okay.
And possibly one of the jobs the view model is going to have to do is to bridge between your underlying domain concept of this piece of the photograph and deal with specific issues like which kind of dots per inch are we dealing with? I've got a photograph with a 400 dot per inch resolution, and I know that my view is going to be working in WPF's 96 dots per inch coordinate system. It's probably the view model's job to bridge that kind of a gap. Okay. So it probably makes sense for the view model to be exposing numbers in WPF's coordinate system.
Okay.
That will represent where it is, what its rotation angle is, and how large it is. Then in the XAML, you would use a combination of an item template and also an item container style.
Okay.
And this is just kind of a technical trick that you have to do, because the structure would be this. You'd have an items control bound to your collection of selection areas on the photograph. So whatever that list is. And then it's going to generate a child of the items control for each thing it finds in that data source.
Okay.
And you want to position that based on whatever the coordinates coming out of the view model say.
Okay, so the X, Y of this item's control, this...
Exactly. And that's not a job for the view to decide. Yeah, generally speaking, you'd say the position would be the view's responsibility to decide.
But in this instance, it's not, because my model is this scanned photograph. I want to find the selected areas, map them to this photograph, and then I want to save off these wallet-sized photographs.
Exactly. So this is definitely the domain of the model, and through that the view model. So you need to make sure the position is handled. And the slightly complicated thing with the items control is it generates the child items directly into whatever panel you tell it to. It could be a grid, could be a canvas. In your case, it would be a canvas because you need the precise positioning.
Right.
But then it wraps them. It always has a kind of a wrapper type. Each items control has a corresponding wrapper type. The list box has list box item. The tree view has tree view item, and so on. Because each different items control has its own behavior for its own generated items.
Right.
Which gives you a problem. Where do you set the canvas.top and canvas.left properties that determine where the thing appears on the canvas?
Okay. Those
only work one level up in the tree. You have to set them on the thing that is the child of the canvas. You can't set them on any old descendant of the canvas.
Okay.
So if I set the position on something in my item template, that's not going to work because my item template is actually hosted.
I see. So where I appear is really within the context of my parent, my immediate parent.
Yes.
So if I want to put all of these rectangles, I can't tell the rectangle, go to the left here. I have to tell it, go to the left within the context of your bounding parent.
Exactly. So essentially what you need to do is tell the bounding parent where it's going to be. And you can do that, and there's a thing called an item container style that lets you do that. The item container style basically says, I want to be able to set properties on the things you're adding to my canvas.
Okay.
And that's where you do it.
So that goes in one direction in the sense that I've got a collection of these things, I guess, and it would be an observable collection.
Yep.
And then I can describe in my styles and do some data binding, and this will say that if I programmatically change the location of these from the code behind kind of pointing upwards towards the screen, then they would move. But then I've got interactions. I'm going to go and hook up mouse downs and mouse moves, and I want to drag one of these controls around. How is that going to work? I pick up one of these selections and I drag it from left to right. What is its coordinate really going to change?
So that's going to have to start in the view, first of all. So you're going to have to add an event handler in the view because that's the only place where you can begin to get those events. And then you would have your view model expose a function that you call every time you get a mouse down, a mouse up, a mouse move.
Okay, so my mouse move event's going to have one line, which is go over here and tell that guy.
Yes.
Okay.
Which may seem kind of annoying and pointless, but that means you can do exactly that same one line of code to fake up mouse input during unit testing. It makes it very easy to give
interesting.
It
okay, good.
fake user
because I'm going to be
inputs.
delegating that, then I can fake mouse moves and test this. Nice. Okay. So then what am I going to do there? I'm going to take from that mouse event args, I'm going to take the new XY, and I'm going to poke it back into the view model.
Yeah.
Which will then flow naturally back to the view automatically.
Exactly, yes.
Oh.
And assuming you're using observable properties with the iNotify property change stuff, that should all just happen.
I mentioned in a talk earlier that observable collection was just like the best thing within WPF. Like that's the thing you're going to find so useful all the time. What is it that's so great about observable collections?
The really nice thing about it is that it means that if you've got just a collection of objects that are meaningful to your application and you add or remove or change the order of those things, you don't have to do anything to make the user interface update itself because WPF is able to capture all those changes. Mm-hmm. It just hooks up the event handler. The items controls know how to do this and then go, oh, look, you just added a new item. I'll generate a new child. I'll build a new instance of the item template, add it to the screen. So you just do one thing that makes perfect sense, add a new object to selected items, and it just takes care of the rest. There's no need to do that manual sort of invalidate H1 stuff you used to have to do before.
There must be a catch, though. I mean, observable collections seem like magic. I've never had any threading problems with them. I'm always adding stuff, removing stuff from them in the code, and it just works.
That'll be because you've never tried to add an object from the wrong thread.
I see. I'm getting lucky.
If you try to modify an observable collection on a worker thread, you will get an exception that says this kind of collection view does not support changes on a thread other than the one that created it.
Okay, well, how many threads are there in WPF and where are they living? Because I know how this works in WinForms. There's
very similar model. It's almost identical model, in fact. There's one thread. It even has to be an STA thread, the old COM single-threaded apartment model thread, because WPF interacts with things like ActiveX controls, the clipboard. It just has to be. And that's the thread that all your events will be raised on. That's the thread that your constructors will be called on whenever XAML is being loaded. Basically, WPF only ever shows you things on that thread. Mm-hmm. So WPF is intrinsically a single-threaded model. If there are other threads, it's because you created them.
I see. So then what is the dispatcher?
The dispatcher is essentially the message loop. If you're coming from a Win32 background, it is the object that presents the programmable face of the message processing in WPF.
So it's not the actual Win32 message loop, but it is is it?
There is one under the covers. It's a little more complicated than that because WPF actually maintains two queues. There's the Win32 queue, which is an ordinary Win32 message loop. And WPF pulls messages off that and puts them on its own queue and then deals with them in its own sweet time. Mm-hmm. Partly because it wants to be able to reorder the events as they come in. It will prioritize certain things above input processing, for example. And that, by the way, is why you get the slightly bizarre repaint handling on resize and WPF applications. You may have noticed you get a little bit of blank space appearing temporarily when you resize a window. Mm-hmm. It's because it's acknowledging the resize event before it actually really does anything with it, and the paints happen slightly out of sync with what's normally there. So there is a Win32 message queue, but it's not actually the main message queue in WPF. Mm-hmm. But that's all kind of implementation details. The dispatcher tries to hide as much of that as possible.
WPF, I mean, how much of it is all new, fresh? I mean, is it truly the windowing system for the future? Because if Explorer in Windows 7 isn't written in WPF, and Office isn't written in WPF, and Zune isn't written in WPF, and Media Center isn't written in WPF, then what's it going to take for people to really believe that this is the next new thing? I mean, is it going to take us writing Office 2020 in WPF before people go, all right, now they're serious. Look, Explorer is written in this thing.
Well, maybe you could at least write the development tool in WPF.
We are doing that. That's true. Visual Studio 2010 is WPF.
Yeah.
That's a pretty good start.
Yes.
But you know what I'm saying.
I do. I mean, there were a couple of questions you kind of folded in there. There was the WPF's credibility, but also is WPF genuinely new?
Which I think applies kind of to its credibility. I mean, I know, for example, that WinForms itself is a managed kind of thunking layer on top of, Win32 itself.
Yeah.
Is WPF a lie on top of WinForms, or is it a whole new thing?
It's a lie on top of other things. Mm. So the input handling is still the same because there is only one way to get mouse, keyboard, stylus input from Windows, and that's through the message queue.
Okay.
So it has to interact with that, but it does not use the GDI rendering system or GDI Plus. It doesn't use device contexts. Instead, it's a lie built on top of DirectX.
Okay, and that's why it can get faster if you have a better video card.
Yes, and it also has a completely different approach to composing all the different pieces of the UI onto the screen, which is why you can do things like sort of partial transparency and overlap and all the sorts of things that were a pain to get right in visually interesting applications in Windows Forms. Mm-hmm. So it is a genuinely new rendering engine. The user event input processing is based on top of what was there before, because otherwise they couldn't have got it to work on Windows XP. Fundamentally.
Oh, I see.
So, as for the credibility, I think Visual Studio being built in WPF is going to be a big deal. Not just for WPF's credibility, but also for WPF's own good. The fact that developer division at Microsoft is building their own stuff on top of WPF means that there's a lot of work is going to have to be done. They'll find problems they probably would not have found otherwise.
Right, making something this big and this complicated. I mean, and the editor is all WPF, and the menus are all WPF.
Yep.
Add-ins are going to be written in WPF. It's really going to make WPF better. And I assume that they're finding errors. I think there was some discussion about performance. They're improving font rendering. All of this is just going to make WPF and .NET 4 and going forward better, I hope.
Yes, I mean, it really has to. And it's interesting, if you look at what's new in WPF, on the face of it in version 4, there doesn't seem to be a big kind of overarching theme. I did a talk on it here this week, and I felt a bit embarrassed that I was basically talking about 15 unrelated things.
Right.
But on the other hand, it's kind of the sign of its maturing as a platform, that it's lots of little things that kind of needed doing.
Right, I mentioned it too, and I was like, hey, there's a grid control, and then silence. But there's a million little things.
There's lots
of
tiny things. Right, so the text rendering, there's graphics performance improvements, there's better integration with DirectX and XNA, there's the ribbon control, there's better shell integration, so you can get hold of the properties of stuff on the file system, you can find out what icons they are, you can interact properly at last with Windows Vista and Windows 7 dialogues. Exactly. It's all sorts of stuff where you probably would go, oh, did it not already do that? But this is exactly the sort of thing you would expect once Microsoft starts building real applications on top of it. And I would say that probably if you look at it from products like Office's point of view, that team in Microsoft could easily say, well, we're not going to do it until developer division has built their own stuff
point.
on top
Okay.
of it.
Yeah.
So it has to happen in that order.
Chicken and the egg situation there.
Yeah.
Okay. So you wrote a book.
I co-wrote a book with Chris Sells,
Chris Sells.
which is known slightly annoyingly as the Sells WPF book.
Yeah, and I apologize. Yeah, it's a problem. You wrote a lot of it.
I wrote slightly more than half of it.
And that book is called?
That is called Programming WPF. It's published by O'Reilly. It's currently in its second edition. We will be doing a third edition for WPF version 4.
Okay.
I'm working on that later this year. I don't have a ship date for that
All
book
right.
yet.
This is now to be known. I want to let all the listeners know that this is the Griffiths WPF book. And you're also a WPF consultant, and people can find you on the web.
Yes. So I have a blog, Ian G. That's short for Ian Griffiths. Ian G on Tap is my blog, so that's easy enough to find.
Ian G on Tap. Well,
Yes.
Thanks so much, Ian G on Tap, for sitting down with me here and talking to me about WPF.
It's been a pleasure.
This has been another episode of Hansel Minutes, and I'll see you again next week.